Hello guys, so in this short video, I'm gonna highlight a very basic and very, essential concept, which is, the little endians and the big endian notations or way of storing data. So we have a memory. This memory, has locations. Each location is 1 byte. So if you have a data which is more than 1 byte, 2 bytes, for example, how the data will be stored in the memory. So there are two ways to store the data in the memory. One way is called the little endian, and then the other way, which is the opposite basically, which is big endian. Okay, x86 use little endian style. So what is the difference between them? So if this is the memory, basically the data segment in specific, the 64-bit data segment. If you have, locations like this, and the first location here is, let's say zeros or, 4 zeros. Let's assume so. This is just an assumption. And the last location is 4. If we know it's a 64 bits, 64K byte. So, the distance between the first and the last location is 64, byte. Okay. So what is little endian and what is big endian? So let's assume you have, an example like this, okay, in which you move data, which is 35F3, which is this is 16 bits, into AX register. AX is, 16 bits. AX has two, as we said last, when we talk about registers last lecture, is composed of two registers, AH and AL, A high, A low. Okay. Then we take this data, which is in AX, and we store it in the data segment in this location offsets with an offset of 1500. So let's assume this is the location, 1500. So this is, if we start from 0, so the displacement will be the same location of the, the byte in which we start to put our data. So our data is 16 bits, 35F3. This is 8 bits. And this is also 8 bits. So where we should put the 35 and the F3. So the 35 will be a byte, 8 bits. The F3 will be another byte. In the little endian, style, you put the lower byte, the lower significant byte. This is the lower or the least significant byte in the lower address or the smaller address. So we're gonna put here in the 1500 F3, and you put the most significant byte in the higher address. So if the lower byte is 1500, then you put the 35 hexadecimal in 1501. This is what the little endian style. Little endian style of storing data. And of course, the big endian is just the opposite. You will put the F3, the least significant byte, in a higher address and the most significant byte in a lower address. But x86 adopts the little endian, style. So as we said here, the location in the data segment 1500 will contain the F3, the least significant byte, and the higher location, which is 1501, will contain the 35 hexadecimal, which is, the most significant byte. Okay, let's take another example. So we have a data segment. And we have at a location which is 6826. We have 48. And the higher location has, which is 6827, has 22. And we are x86. So we deal with little endian style. And we performed or executed this command or instruction, move bx and 6826. So what's in that location will go to bx, but bx is 16 bits. So actually what's in this location, 6826, and the following one. This following might be a lower or might be a higher based on the style that we adopt. x86 adopts the little endian, so it will take it and the higher one. So we're gonna target 6826, 6827. bx is 16 bits below b high. So what will go to b low and what will be in b high? Since it's a little endian, the least significant bit is in the lower address, or significant byte, I'm sorry, least significant byte, which is 48, will go to BL, and the most significant byte, which is 22, will go to BH. Okay, guys, that was it for the little endian and big endian styles of storing data. Thank you very much and see you in the next video. Bye-bye.